Hello everyone. This is part 2 of homework 10, and last time we saw some situations where we were given a partial table of values of x or y, and we were asked to solve for the other coordinate in the ordered pair. So we continue with that concept, and in number 3, you can see we have the same situation, a 3-part question, column A, B, and C. And in part A, it's telling us to let x equal 4, let x equal 0. So when x is 0, if we substitute into this equation, we have y is 1/4 times x, or y is 1/4 times 0. And really no need to literally show that substitution, because obviously 0 times anything is going to give us 0. So 0, 0 would be an ordered pair. In part B, chooses kind of a large number for x and kind of a value that's not really typical. But there is a reason why they chose 16 negative. And that's because when you substitute it into the equation, again our main equation, y equals 1/4 x, we get a cancellation because we have 1/4 times x, which is now negative 16. You could treat that as negative 16 over 1 if you like, but the 4 goes into 4 once and 4 goes into negative 16, negative 4 times, so we get negative 4 over 1 or negative 4. And that's actually desirable to have situations where fractions are not involved. So the idea of choosing negative 16 was that 16 is actually a multiple of this denominator, which is going to come into play in the future and be a very important concept. So it's nice that they mentioned it here. But just finishing this up, part C says, now when y is 5, so pay attention to the columns, and we're given that y is 5. So if y is 5, we have that 5 is equal to 1/4 x. And here's a situation where you could choose to, since the coefficient of x is a fraction, you could choose to multiply by its reciprocal. Or, as I've done in the past, I like to use the the cross multiplication method, where I'm going to write this 5 as 5 over 1, and instead of 1/4 times x, I'm going to write it as 1x over 4. Let the x be absorbed into the numerator, because then I can think about cross multiplication. And 4 times 5 is 20, and 1 times 1x is just 1x, or just x. And so that gives us the value when y is 5. Okay, so another example of the same type of situation. And here we first, again, 3 parts, A, B, and C. And in part A, we're told that x is going to be 0. So when x is 0, okay, so this is our go-to equation again. X plus 3y is 15 is the given. Replace x by 0, so 0 plus 3y equals 15. And sometimes when the coordinate is 0 that we're substituting, there's no need to show the literal substitution like I did here, because obviously if x is 0, that term goes away. You could almost solve the resulting equation by inspection, because what we get, as we could see literally here, is 3y equals 15, and then we're just going to solve for y by dividing both sides by 3. So y would be 5. So 0 and 5 is a point. And then here's a tactic that is often used that again will become important a little bit later. We'll revisit this concept of creating our own table where we have to choose the values. And many times it's convenient to choose x to be 0 on one occasion and then let y be 0 on the other occasion. And that's basically what they're setting us up here for. So here, and that will have significant meaning in another lesson or two. But here when y is 0, okay, I'll show it literally. X plus 3 times y is 0 is 15. But see, literally the substitution is not necessary, because if you replace y by 0, that term goes away, and you can see the answer right away, x equals 15, which obviously is what we get here when we show it literally. Okay, and then in the final part, they're telling us to choose y to be 2. And if y is 2, we substitute once again into this given equation, x plus 3y. So 3 is being multiplied by y, replace y by 2, put it in parentheses, a multiplication symbol works as well. Recopy it, equals 15. And then solve for x. We'll first multiply 3 times 2, carry down the x, plus 3 times 2 is 6, is 15. And then subtract 6 from both sides, and we get that x is 9. Okay, now these are all ordered pairs, and in this example what we're actually going to do is complete the table as we've done in the previous examples, and we're actually going to list the ordered pairs and then plot the points and graph the corresponding line. So this is something we need to get used to doing. Again, there's 3 parts. Consider part A, B, and C. And in part A, telling us to let x equal 0. So when x is 0, here's our equation, 2x minus 5. Y is 2 times 0 minus 5, or just minus 5. See, and we can see that again by inspection. If you just let x be 0, the term's gone, containing x, and you can literally see we get y equals negative 5. So skip steps if you like. But now I'm going to list the ordered pair, 0, negative 5. And we'll plot that momentarily. I think I'm going to wait and do the rest of it. We'll do part, and then we'll plot all 3 points at once. So part B is when x equals 2. Okay, then we get y is equal to, again, the go-to equation, 2x minus 5. So 2 in parentheses, substitute x is 2 minus 5. And then just do the arithmetic, I guess, in this case. 2 times 2 is 4 minus 5, and 4 minus 5 is negative 1. So 2 and negative 1 is an ordered pair. And note that when you write the ordered pair, you have to separate the x and y values by a comma enclosed by parentheses, as we said earlier. And then in part C, now we want to choose y to be 3. Okay, and so we get 3 equals, so again into this equation, y equals 2x minus 5. So y is 3 equals, just recopy, 2x minus 5. And then solve for x, so we have to do a little bit of algebra here. Isolate the x, add 5 to both sides of the equation. Get 8 equals 2x, and finally divide by 2. And we get that 4 equals x, or x equals 4. So 4 and 3 is the other point. Now I haven't said this yet, but it actually only takes 2 points to define a straight line. we typically find 3 because we want that third point as a check, to see if the points are lining up, because all 3 points, of course, should line up. So let's see if that's true by just plotting. Let's plot points A and C. So if I plot point A, that's 0 in the x, y is -5. So that's right here. And let me plot point C, 4 and 3. So I go over 4 in the x, 1, 2, 3 in the y, and that's right there. So now if I use the straight edge to join those points, there's my straight line. And again, well, I should have labeled the axes to begin with, x and y, but then if we're doing this by hand, might want to write the equation of the line next to the line. But notice how the point 2, -1 is a point on the line. 2 in the x, -1 in the y, and that's right there. That's a point on the line. So see, all points should line up. You could use that third point as a double check. Okay, so here's a quick word problem, an example of why we're doing what we're doing. Let's suppose that the cost y in dollars of producing X footballs, so X is the number of footballs produced, is given by this equation, y equals 80x plus 5,000. So we want to complete the table. So there's really 3 parts to this. Well, since that's labeled A, I'll label these as 1, 2, and 3. Okay. So the first one, when x is 100, then in the equation we have y equals 80x, so 80 times 100 plus the 5,000, don't forget that, so that's 8,000 plus 5,000, which is 13,000. So basically what it's saying is that if you want to produce 100 footballs, it's going to cost you $13,000. And then we have a couple other values of x. And you really don't need to show all the work that I'm showing, because obviously it's just a matter of plugging in the x and crunching down the y's. But in part 2, x is now 200, so 80 in parentheses 200. And don't forget the plus 5,000. So just to make sure I'm not making a careless mistake, 80 times 200 is 16,000, plus the 5,000 is 21,000. So we'll fill that in. And then finally in part 3, when x is 300, then y is 80 times 300, again plus the 5,000, so that's 24,000 plus 5,000, which is 29,000. Okay, but then it says in part B, find the number of footballs that can be produced for $8,600. So the number of footballs represents x. So it's basically saying x is question mark, what is x? And the cost, recall, is y in dollars. So this is the value of y, 8,600. So it's basically asking us to find the x-coordinate when y is 8,600. And the equation, once again, was y equals 80x plus 5,000. So we just simply substitute, replace y by 8,600. So substitute, replacement, whatever you want to call it, 8600 will equal 80x plus 5000. And now we'll solve for x. And to solve for x, we first transpose the 5,000. So subtract 5,000 from both sides. And we get 3,600 equals 80x. And then to solve for x, we divide by 80. So the 3,600 gets divided by 80 as well. And just to make sure, 3,600 divided by 80 on the calculator is 45. So then you might want to write a nice college-like sentence. We can produce 45 footballs for $8,600. And just as a note, this should make sense with respect to the fact that when we filled out our table, 100 footballs cost 13,000. So at least it makes sense with respect to the fact that 45 is obviously less than 100, and our $8,600 obviously less than the 13,000. So if we, let's say for example, ended up with 450 as our answer, then you know you did something wrong, because it costs way more than $8,600 even to produce 300 footballs. Okay, so that's the end of homework number 10, and we'll see you when you are ready for homework 11.